You've connected? Huh? You is it connecting?
How are you, sir?
Yes, Prof. How are you? Thank you.
You've just created it now.
Yes, less than 2 minutes. You've seen it? Huh?
There's one which is like this.
322.
Yes,
You've connected?
yes.
Okay. All right. Yeah, so you just get the link and you share. Share the link, okay?
I've done that, sir.
Very good. Have people joined?
Yes.
I can push that button. Okay, we can start. I can see 3 people have joined. So we can start and see how far we can go. If I'll be able to manage to finish the topic that we had started, the better. Okay. All right, we can get to our notes. I should mention that I've received the labs but some were just received today, so they are late, and we'll have to do some subtraction there on the marks. Some are late. Okay. Last time when we met, we started looking at some Boolean expressions. I think that's where we ended our class. We're looking at Boolean expression. And we also looked at, in short, we had started chapter 3, which is branching and looping. So we started looking at the if statement. We went to the Boolean expression. And we also looked at the difference between the single equal sign and the double equal sign. Then we also looked at, I think we were supposed to start what is called the while loop. That's where I will start from. So this will take us to the do while loop, the for loop, and then you look at an example which will end our chapter. Then tomorrow when we meet, we'll start looking at chapter 4, which is called arrays. So even as we break today, it's better you go and go through chapter 4, which we are going to look at tomorrow. All right, so today I'm just going to conclude chapter 3 by starting with what is called the while loop. Let's go to page number 16 of our notes. Okay, page number 16 of our notes, we are saying that when we are looking at the while loop, you will find that while statements are just as easy to use as if statement. So we started with the if statement. As an example, we said if, for example, a is less than 0, then the program should do something. If a is in between, is equal to 0, if a is greater than 0, so you are giving the condition. Now, the while loop is just as simple to use as that of an if statement. For example, let's go to page number 17. You see that example that we have there. On page number 17, we have an example. Remember when we looked at the if statement, we were giving the conditions. Now, that simple program that you see on top there, it's saying while, in brackets, there's A is less than B. So you open brackets, you print F. Then you have your percentage D / NA, where A must be equal to A plus 1, and then you close. So what is the meaning of this program? This causes the two lines. Mark that. This causes the two lines within the brackets to be executed repeatedly until A is greater than or equal to B. In other words, the program will be in a loop until the condition A is less or greater than B. That's when the loop will stop. In other words, that's when the program will stop running. The while statement in general works as illustrated to the right. So, in other words, while it means that as in some way we would say as long as, that could be the while statement. As long as A is less than B, this program must print this. As long as A is less than B. Now, in an event that A becomes greater than B, the program should not do anything. That is what we are trying to say. All right. So the next thing that we want to look at is the do while loop. So the one that we're looking at is a while loop. A loop is just like a complete cycle. So there is the while loop, there is a do while loop. So if I ask you in an exam to say differentiate between a while loop and a do while loop, you should be able to differentiate them, or able to differentiate them even using a program. So C also provides what is called the do while structure. For example, on page 17, we have do open brackets. So you can use that do. C programming will understand what you are saying there. So do open brackets, print that. We have used the same example that we have on top there. And then at the far end, you say while A is less than what? Is less than B. This is a do while. In other words, in the same program, you have a do and a while statement. That's why we are calling it a do while. It's one word. So the program must do the following as long as A is less than what? Is less than B. So while A is less than B, the program should do what is above. As long as this while statement is actually maintained or is actually, satisfied, it means that this program will do what we have instructed the program to do. Now, we move on to what is called the for loop. So remember, there is the while loop, there is the do while loop, there is the for loop. In other words, I would ask you to define all those and see their differences. So they are so close related to each other, but you must be able to separate them when it comes to their definitions. For loop. The for loop in C is just simply a shortened way of expressing a while statement. For example, suppose you have the following code in C. Let's look at an example down there. Given that x is equal to 1, while x is less than 10, we should actually print the following, blah, 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 what you have in there. So that this is just the same as saying that. Now, again, you close. What is there is, look at the statement that is just after the for loop. The for loop in C is simply a shorthand way of expressing a while statement. While statement, as long as this condition is satisfied, the program should do the following. So the shorthand is just like the for loop. In other words, for this condition, while A is less than B, for the condition that A is less than B, that's why it's like a shorthand. So when you're asked the difference, the difference is that the for loop is just the shorthand of writing a while statement in a what? In C programming. That is what you say. So what is there is, look at that example that we have. X is equal to 1. While x is less than 10, we should do the following. Blah, 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 blah. Okay, that is not the program that is down there. It's just to illustrate that you should do the following. So you can put any other program that you want there. Now, if you want to convert this from a while, you see that we have used while x is less than 10. Now we want to convert it to a for statement. In a for loop statement, what we have is that you can convert this into a for loop as following. So, for, remember the first program was x is equal to 1, while x is less than 10. But now we are saying for, in other words, the condition that x is equal to 1 and x is less than 10. So what is there is the program should print the following, blah, 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 right? So note that the while loop contains an initialization step, x is equal to 1, a test step, which is, so the initialization there is x is equal to 1. That is the first condition. The testing, should the program run or it shouldn't run? The test is x must be less than what? 10. So the moment that is tested, then it means that the program will determine whether to run or not to run, and an increment step, which is x plus plus. The for loop lets you put all three parts into one line, but you can put anything into those three parts. For example, suppose you have the following loop. For A, we have set A to be equal to 1. B must be equal to what? To 6. Then, while A must be less than what? B. This is a while statement. So it means that A++ must print F of that. Now, we want to change this while program that we have under page 18 into a for statement. So you can replace this into a for statement. Look at the first program that we have there. A is equal to 1, B is equal to 6. While A is less than B, it means that as long as A is less than B, this program must do the following. Now, if you put that into a for statement, it means that you need to collect all those three conditions. The first, which is an initializer, is A is equal to 1 and B is equal to 6. The testing part is A is less than B. It means that we need to put the A++ there. You can put anything there that needs to be printed. And then you have to print the following. Now, it is slightly confusing, but it is possible. The comma operator lets you separate several different statements in the initialization. So a comma is actually separating those statements. So that is a statement in the initialization and increment sections of the for loop, but not in the test section. Okay, many C programs like the pack like to pack a lot of information, of course. So what we are saying is that a comma is used to separate those statements so that when the program reads, it reads each statement before the comma as a separate entity, and it has to execute that separately. Okay? All right. Now, let's look at an example on page 19, which is looping as an example. Okay, let's say that you would like to create a program that prints, okay? You are printing those Fahrenheit to Celsius conversion table. So in other words, we are converting some 1 unit to another unit. So we want to convert in a table form. What is it going to give us? So what I would request is that if you have a computer on with you, you can easily type that program. Just easily try that. You try to type that program that we have there, include studio H, integer, main void, int A must be equal to 0. While A is less or equal to 100, you should print the following. Degrees, which is F must be equal to this. So you are converting the Fahrenheit to a Celsius. So that, and that the condition A must be equal to A plus 10. Then it must return what? It must return 0. So if you run this program, it will produce a table of values starting from 0 degrees, because we have said that A must be equal to 0. So the first value for A must be what? 0. So it will start from 0 degrees F and end at 100 degrees F. The output will look like this. So it will start from 0, then it will just be continuously, because you've said A must be equal to A plus 10. So it means that the value of A, it will be adding 10. From 0, it adds 10, it comes to 10, it adds 10, 20. That's why you have 0, 10, 20, 30, 40, up to 100. Then it will now be converting according to what you've stated in the formula that you've used. So the table's values are in increment of 10 degrees. You can see that you can easily change the starting, ending, and increment values of the table that the program produces. So you can easily change that. You can change the initial value of A if you want. You can change the increment. You can even change the testing values so that you can have a broader or a shorter version of your readings. Okay. Now, of course, if you wanted your values to be more accurate, you could use the floating point values. Of course, these floating point values, we'll understand them more as we go and as we go on and study the examples that we have. Okay, so let us look at the programming exercise on page number 22. So page number 22, try changing the Fahrenheit to Celsius program so that it uses scan to accept the starting, ending, and increment value of the table from the user. And then you add a heading line to the table that is produced. Then try to find a different solution to the bag fixed by the previous example. Then from there, you create a table that converts pounds to kilograms or miles to kilometers. So do that and you submit before the end of this class. Let's try that. You can try that right away and make a submission. So that ends chapter 3. Tomorrow we shall start on chapter 4, which is called arrays. And most likely, since you'll be coming the other week, our wish is that we can, by the time we come on, by the time we come back the other week, we should be looking at chapter 7 when we start the physical classes, so that we'll see how far we can go. Okay. All right, so start that, do the program. I'll be waiting for that program. It's an exercise which is on page 22. So you have, I need 2 programs that it uses. So you go to the example that we have. That program, you see it on page number 19. That is the example that we are talking about. So that example is on page. So you get that program the way it is. Then you actually use scanf to accept the starting, ending, and increment value of the table, and also add a heading line to the table that it produces. So I need to see the heading on the result that you get. So I'll be waiting for that, and please send to my WhatsApp before the end of today. Thank you so much. Wish you well. Okay, I think we are done.